Okay, so we've been looking at different ways to assess the fit of the regression model. We looked at residual plots, and another way to assess the fit of the model is the standard error of the estimate. So we denote S sub E as the standard deviation of error. And so if we wanted the variance of the error, we would do S sub E squared. So we'll get to the formula in just a moment. And what that is if the normality assumptions of the regression model hold true for the data used, then the empirical rule holds. So that means 68% of the data is expected to fall within 0 plus or minus 1 standard deviation of the errors, and 95% are expected to fall within 0 plus or minus 2 standard deviations of the error. And so the researcher can use this information to make a judgment about the fit of the regression model to the data. And it really is dependent on the context of the model. So if you're talking about sales, then it has to be done in context of the sales. And then you have to ask yourself, does this make sense? Or is this acceptable? So we'll look at an example using our online sales example from the earlier slides. So the standard deviation of the error is also used to test the magnitude of errors in the model, and it can also identify any potential outliers. So let's look at the formula here. The formula for the standard error of the estimate is going to be the square root of the sum of the squares of the error divided by n minus 2. So n is the number of data points in the model. So if we wanted the variance would be SE squared, and it would just be simply be the SSE, so the sum of the squares of the error divided by n minus 2. So without the square root, you would square that value to get the variance. So there's 3 different ways you can calculate it. The SSE part. So you could have the residual squared, so y minus y hat, the sum of those squared, or you could use the sum of the squares for the y multiplied by 1 minus the correlation coefficient squared, or you could use this part of the equation, so the sum of the squares of the y, subtract the sum of the squares xy, so SSxy squared divided by the sum of the squares for the x's. So it really depends on what you've been given. So I'm going to use, for our online sales example, I'm going to use the middle one to calculate the SSE. So I'm going to get the whiteboard here. And so the SSE in our case, using the previous slides, so you might have to look back at the values of the previous slides and get SSYY, multiply that by 1, subtract the correlation coefficient squared. And so if we plug in the values, again, these come from the example that we were working on previously. The SSYY was 1265.2 multiplied by 1, subtract, now the correlation coefficient that we got from our model, our data, was 0.97699. Remember, there was this very strong correlation between the time spent on using the online chat feature and the sales. So that was the correlation, 0.97699. We square that value. And so if we plug all that into our calculator, we get 57.555. A little bit of rounding there. So the variance of the error would be SSE divided by n minus 2. I believe we have everything now. So 57.555, subtract, we had 5 points, right? N was equal to 5, subtract 2 will be 3, because we had 5 customers. We plug all that in and we get 19 So 19.185. So now to get the standard deviation of the error without the square root there, so we're just the standard deviation of the error, we take the square root of 19.185, and that turns out to be, and please check this, 4.38. So what that means is 0 plus or minus 2 SE, so 2 standard deviations, in our case equals 0 plus or minus 8.76. And so that means that 95% of the errors are within $8.76. And that seems reasonable, but this is a good way to assess. So 95% of the errors are within $8.76. So that's useful to have. And so that means we have a good model, and I don't suspect any outliers. Another way to assess the fit of the model is with the R squared, this value here. And so in the next coming slides, we will look at how to calculate R squared.